Lecture 7, Distribution, Deviation, and Correlation. Okay, so what we're going to do is we're going to continue our exploration of analytical patterns, and this time we will talk about specifically distribution and a little bit about correlation. All right, so this specific course lecture, we have actually one file, distribution, deviation, correlation. It's just one Tableau extraction, so I'm going to work on this file only. Okay. Now, last time we kind of talked about some patterns, and we actually did quite a bit with deviation patterns. So today our focus will be distribution and correlation. Once again, we're going to hit many of these charts that you see. Some of them we have already hit, but there are others that we haven't touched upon. And of course, there will be some perhaps we won't even touch upon at the end of the course. Now, in terms of deviation, we talked about this quite a bit. So we basically said, how do you measure deviation from some reference value? The reference value could be, average, could be some specific value that you choose, or it could be like in some examples that you may have, like you may see, this is very common, actual versus budget. Okay, so how much you deviated from the budgeted amount with the actual that you actually recorded. Okay, state sales versus average sales per region, that we did also. So population sales, population divided by sales, change compared to fixed date, say 2010, and we did quite a bit of this as well. Okay. So, but the goal is you can show these deviation analysis using bar graphs. That's what we did. Line graphs when you can actually have the underlying data has like interval scale, such as time series. We did. But two practical issues, techniques that we did already use is expressing deviations as a percentage. Okay. So this is, of course, it's very critical when we do this, and we need to think about how we re-express data, right? Such as using percentages and comparing deviations to other points of reference. Okay, so we could also compare them, like what is the how do you select the correct reference point? Okay, of course, you have to be consistent in terms of both in time and space when you do the comparisons. The reference point, it has to be consistent. Now, today we're going to do distribution analysis. That's my main focus. Right? So the idea is to show how the underlying values are distributed from the lowest all the way to the highest member in a group. Okay? Our data will be based on what you've done already with assignment 2. Assignment 2, you had this nations data, and I'm going to use the same data for this example. Okay. So there you did a lot of tree map analysis, data formation, transformation, and using colors, as to modify your charts. Okay. So today we will look at distribution. When it comes to distribution, you can actually measure distribution using measures of centrality, like median or mean. You can look at the spread. Statistically, you can look at spread using, just simple low, high, or range, high minus low, okay? Or you can look at the shape. There could be complex measures of shape. You could be like skewness, kurtosis, all kinds of statistical variables that you can use for this, okay? Alternatively, you can use what is called the 5-value summary. So you look at the percentiles, 25th percentile, median, 75th percentile, and low and high. Compared to this, this is called the 5-value summary, and we're going to do this with box plots shortly. So what you basically have is you take your distribution, divide it into 4 pieces. Okay. So on the left you have the lower, on the top, on the right you have the higher. Okay. So the whole 100% is distributed over here, and then you find out where exactly is your 25% of the population, lower 25, and then you have. So since I made this larger, so this is your higher 25%, okay? And then you have here the middle 25%, okay? So this is the idea. So you basically have Q1, Q2, and Q3. These are your first, second, and third quartiles, okay? So the idea is find these numbers. And these quartiles are sometimes called low hinge, high hinge, and for median it's also called mid hinge. So we're going to look at all these. They're also called box and whiskers plots. So we're going to look at these and create them in Tableau, and then of course analyze them. Now, when we do look at distributions, we're going to consider a bunch of patterns. Okay, so I'm going to draw a few and then go ahead and, so for instance, what is this shape? Once we have the distribution, and we're going to create distributions using histograms. I'll show it shortly. Shortly I'm going to show you, right? So what is the shape? Is it flat? So if you have the distribution, let's say you create the histogram, does the distribution look like it is flat? Okay, so flat means somewhat flat. It doesn't have to be exactly flat, but this is a distribution. So this is basically frequency. So these are your bins. Okay, so let's say this is your bins, and this is your frequency. Okay. So how many units are in these numbers? Let's say this is 5, 0, 5, 10, 15, 20, 25, 30. So your bin size here is equal to 5. Okay. So we want to create, we'll do this in Tableau, we'll create these histograms and we'll understand what the shape looks like. So this is your flat distribution. Alternatively, your distribution could be curved. Okay, so the curve could be like normal distribution kind of curve. Okay, doesn't have to be perfect, but somewhat like this. Okay, so here is your flat versus curve. So there are also other issues that we need to consider. So I'm going to go ahead and remove this. All right, remove that as well. So I'm going to actually take this and expand. Okay, I've already created all these different alternatives. Okay. So let me expand this. Right. So these are all considerations. Curved versus flat, one of them. Upward, here, let me mark it. So here is the curve versus flat. Okay. Is it upward curve or is it downward curve? Another concern. Is it single peaked like this, or does it have double peaks? Okay. Is it skewed? Here you have a left skew, here you have a right skew. So which side of the distribution is kind of pulled farther? Okay. Do you have concentrations like this? Here you have actually a big concentration of values, right, in that range. Okay. Do you have any gaps? So here are the gaps. So you have kind of two peaks, but there is a gap between, so it's not like smooth. Okay, so how big is that gap? Okay, and are there any outliers? So that's also another issue. So when we look at this, these are all considerations that we have to, when we look at a picture of a distribution, these are things that will immediately strike us. Now I'll talk about outliers a little bit more. Now if you have displays, you can actually display these distributions using histograms. Okay, so you can create discrete bins and you can aggregate by bins. We'll do that. You can use what is called frequency polygons. It's like a continuous line graphs. Okay, frequency polygons are relatively simple. We are not going to do this. So basically what you do is you have, let's say you have an histogram. Okay, so to create a frequency polygon, so let me switch colors here and size. So what you have is a histogram, right? Let's say this is your histogram. Very simple. Okay. So what you do is you take the midpoints, each of these histograms. Okay. Right? Just the midpoints. And then you draw lines. Let me change color quickly. So you draw these lines. Okay, so this is your frequency polygon. Okay, so what then you do is you remove these, and this is what you're left with. Okay, of course I kind of remove this, but let's start from 0. So this is your frequency polygon. It's just like histogram, but you're just combining, just connecting the lines from the midpoints. Okay. All right, so let's get it back. All right, so that's what frequency polygon is. All right, let me put it on the side. I can just when I post these, I can actually post that as well. Now, strip plots we're gonna do, they're like dots on a line, but you can also show each point in the distribution, not like aggregation, like histogram. Histogram you aggregate, right? So all these points that are in that bin, like all these points that are in the bin, only thing that you do for each bin is count how many units are in that range. They could be all mashed up right here. They could be all on this side. You don't care, okay? So in histogram, as long as they are in that bin, they're counted equally. So however, we can do this a little bit differently with strip plots. I'm going to do those in Tableau shortly. Okay. Finally, we do what is called the stem and leaf plots. And these are created, and they're created by John Tukey a long time ago. And they are kind of histograms. So what you do is you take these numbers, right? So you have these numbers in a set. So what you do is you go ahead and start writing these numbers out. So let's basically say, so here I'm going to write anything between 0 and 10, 11 and 19. And then just like bins, right? 20, 29, 30, 39, okay? So something like this. So then you put numbers. So this is your stem, and then you put leaves. So each leaf is a number. So you go through this. So the leaf is then the tens. So for each number, you take the tens digit, and then you write it next to each bin. So for instance, you go through 15. So tens value is 5, and you put it in the second. So you put it right here. 21 goes here, but only take the tens. 14 goes here. 13 next to it. 22, 3, 9. So that's 22, 23, 29, and 5 goes to the first bin. 6 and 7 also. 31, let me put 31 here, and 28 goes there, okay? Now, once you have this is called a stem and leaf plot. Actually, if you take this and turn it sideways, what you have is actually you have an histogram, okay? This is how your histograms work. So if you put bars around this, so these are frequencies for each bin, okay? So this becomes your histogram. All right, so it's like a vertical histogram. Now, we're going to use nations CSV data, and then we'll do all these charts. We'll do histograms, we'll do strip plots, and then we'll do distribution delays. We'll look at box plots, multiple strip plots, frequency polygons, distribution deviation. So we're going to do all this. So what I want to do now is, before we go at it, I'm going to go and start creating some charts. All right. Now, hey Birdie. Now, the finished product is already posted. So let me show you what it looks like. Okay. So we have this nations data set. So let me fit this. And what we do is, first of all, let me remind you what this data set has. And this was your assignment too, so you already know this data set. So you have a bunch of dimensions: country, income, and then the country codes, life expectancy is a bin, and then the region and the year. We have 2 years, just like you did in assignment 2. We have a year which is continuous, and there's a discrete version of this. And then you have a bunch of measures: birth rate, GDP per capita, life expectancy per year, neonatal mortal rate, population, and so on. So what I'm going to focus this time is I'm going to focus on life expectancy, and also related to GDP per capita, right? So over the years, I want to see how life expectancy changed for various regions across the world. So our data starts from 1990 all the way to 2014. Okay, so this is the data I've gotten from online source, and I think I've described the details of this. Okay, so this is just a file that we're going to import and start using. Okay. All right, so let's go ahead and do this. So I'm going to do all of this from scratch. So what I'll do is I'm going to go to File and say New. Let me get this out of my way. Right, so we're going to now the next thing we'll do is I'm going to connect this to text file, which is because CSVs are called text files, and this is the nation CSV I shared with you. And I'm going to click Open. Right? This data, as you notice, is already pivoted. So each year for each country, I have GDP per capita, life expectancy, and you see that there are some nulls. Some years, some data is not available. And this has a lot of data. You notice here, GDP per capita for Aruba was $36,000, and then life expectancy was around 75 years. Okay, and the population was 101,000. Right? So, okay, so it's the data, right? So next thing I'm going to do is I'm going to go create some charts. Now, before I create charts, one thing I ask you to do in your assignment as well, to create a year which is a discrete. So this is a continuous year, I want a discrete year. Now, for this specific project, what I'm going to do next, it really doesn't matter. So it will be exactly the same, but I'm going to go ahead and do that nevertheless. So let's go ahead and click duplicate. So once we duplicate, you notice this is continuous. You can convert to discrete. I'm going to go ahead and convert this to discrete. Just to convert to discrete, very simple. And then let me rename this. I'm going to go ahead and name this discrete. Right, so this, if you notice discrete value, so this is a calculated field, but it is not continuous like this. It is a discrete value. So I noticed in the version that I posted, I actually did not even do it. What I did is I duplicated it, but you notice actually this is still not, this is still continuous. And you notice it's gonna work exactly the same way. All right, the first chart is I want to look at how, over the years, how the average life expectancy in the world changed. So I'm going to take life expectancy right here, put in my rows. It's currently it's sum. I'm going to change that. I'm going to take my year. Again, it won't make any difference. I'm going to put it right here. And then next thing I want to do is, since it's discrete, you can see it's given me bars. If I took this away and put year as a continuous variable, you see it will give me a line. So that's the difference, okay? So the continuous variables are going to be treated like continuous, so that the default will be a line, okay? Which is like equally good, so I really don't care. So now I'm gonna do this, and then take the year, discrete. So now I have these bars, okay? Of course, you notice it's increasing over the years. So this is the sum. Let's do the average. So I'm gonna do the average. So this is the average, and you see this smoother. And then the next thing I will do is, since I want a line, I'm going to go ahead and change from bars to a line, okay? I could also choose to do circles. That's what I did. And then I can go ahead and change the size of the circles and make them small, okay? So now you can see how, let me fit this to the width so you can see. So you see that trend, okay? So trend is going up. The next thing is we're going to do, so we have both lines. So I can duplicate this. I think so that I have the exact same charts. So I'm going to go ahead and duplicate this. And this version, then the duplicate version, I'm going to actually have a line. Okay, so instead of a circle, let's have a line. Okay. The next thing I want to look at is I want to look at the income and see how life expectancy, it's increasing, but how is it changing for each income group? Now, before I do this, I have this variable called income, but it is not the way it's sorted, but these are income categories, okay? So I want to sort them in a certain way, right? So I'm going to go ahead and right click on this, and this is what you did already in your assignment, but I haven't done it here. So I'm going to go ahead and change its properties. So one of the properties I will change is sort. So I want it to be not sorted by the data source order, but I want it to be sorted manually. So I want high income OECD to the top. I'm drag and drop, or you can use these right here. And then low, middle, upper middle, right? So low income and non-classified. So high income OECD, high income, upper middle, lower middle, and low income. This is the order I want them to show up before I do that chart. So the next chart I'm going to go ahead and add. And this chart I want the average life expectancy. So let's do this average. And what I want to look at is, I want to look at how this life expectancy is related to income. So grab this and drag it right here. So this is each income group. You notice now, since my data has dates in it, this whole thing is aggregation of all the years for all countries. Okay, clearly you see that the income, as it lowers, the average life expectancy also gets lower. Okay, so that's no question about this. Okay. Now the next thing I want to do is I want to get rid of this not classified. So there's one thing I could just get rid of it as well. I can just say just remove. Okay, so I'm just going to exclude. Okay, so lower, because I don't know what that is, but it's just a anomaly in the data. Okay. So, and then the next thing I want to do is I want to put the numbers on here. So right click on this, or not right click. So it's better to do it this way. Go to analysis and show mark labels. Okay, so that we can see numbers. The next thing I want to do is I want to add years to pages. So I'll drag here. Let me do this. It doesn't matter. I'm going to put it years. And then I'm going to look at the year 2001. I think that's what it is. So the numbers are exactly the same, just to make sure. Okay. All right. So this is what we do. So we look at, create these bar charts so that we can see how different income groups are affecting average life expectancy. Here's a huge difference. Look at the low income countries, 53 versus high income OECD countries, almost 78. Okay. Now the next thing is each of these groups have a bunch of countries, right? I want to actually see how it's distributed in each country. And there are many ways of doing this. And one way to do it is using what is called range bars. Okay. So to create range bars, what we do is we take this same chart, duplicate this. Okay. Right click on this and duplicate. So we want to see each country as a block. So what we can do is we can drag country from the left side to the detail. So I'm going to drag and put it into detail. Okay. As soon as I do this, you see a bunch of countries are listed here. Okay. If I want to get range bars, this is what I'll do. I'll cheat a little bit. I'm going to go to from automatic marks to do a square. So now each country here is a square. You notice Estonia and each group, you can see actually one by one, each country you can see is listed there. Okay. So this is the lowest, this is the highest. But I want it to be a smooth bar. So what I want to do is, first of all, let me I can do that. So fit this. The next thing is I'm going to change the size of these bars, or these squares. All right? I'm going to change it so that it becomes smooth. Okay? So this way I create range bars for each income group. Okay? So here is the range bar from almost going from Estonia all the way up to, I think its top is Japan. Okay? Almost 82 years, 81 and a half years. So each country is represented by a box. So this allows you to create this nice kind of range bars. Okay, so these are bars, but it shows you the range for each income group. Okay, you can now see it, not only this income group has high, like OECD group has high life expectancy, but it's also distribution is not that spread. Okay, so everybody is almost close from 70 all the way up to 81. Okay, right. So this one is a higher range, but you notice even in the high income group there are countries at the top, like Hong Kong is at the top, is as high as Japan, almost same number. Okay, same thing. Even the low income groups, you see some countries are at the top, almost as good as some of the countries in the OECD group. Same thing in the low middle income group and upper middle group. Okay, so this distribution, seeing it side by side, is very useful to understand. Now, of course, we can next thing is we can also look at it from, not from the income perspective, but we can look at it region perspective. So income group, so we now understand now how it changes. So let's look at now the region. So I'm going to actually get the region and then look at the average life expectancy. Let's change it to the average. Now, and then the next thing I want to do is I'll do the same thing. So I'll take country and put it in detail and then change it to square. And then let's make the squares a little bit larger so that it's smooth. Okay. All right. So now it's for various regions. This is how Let me fit this a little bit. So now you can see for each of these regions, you see how the life expectancy changes. Okay. Now, if you look at North America, there are two countries, a couple of countries here. Bermuda, let's see, Canada, Bermuda, and so this is for whole year. So let's get the year again. So that's what I was missing. So let me put the year here as well. So let's look at a single year. Okay. All right. So let's look at 2014. That's what I have posted. Okay. So it's 2014. This is what it looks at for each region. So you notice Sub-Saharan Africa has the lowest. Swaziland has, in 2014, the average life expectancy is just below 50 years. That's very low. Okay. So all of these, of course, there is a story, right? So what's going on in Swaziland? Okay. So what is going on in Angola? So there's always a story, backhand story, why this is so low. Usually it's wars, economy doing very badly, or diseases. Okay. So this actually gives you a nice starting point. All right. So now we looked at each in the region. So this is called range bars, and they're quite useful. Now the next thing is, you notice in each of these, to see each country, we have to actually go and individually look at each country like this, zoom over this. What if I want to see each individual country and still see the distribution? What I can then do is I can actually create what is called a strip plot. Okay, so let's create it. Strip plot is nothing more than just dots on a line. So I'm going to put, what I'll do is I'll take life expectancy. Just like I did. I could copy and paste from the others, but I'm just going to do this. I put life expectancy here. So here are life expectancies. I'll take the year again. I want each year to be analyzed separately. And I want to look at 1990. That's perfectly fine. And then what I'll do is I want to put each individual country. So I'm going to put each individual country. As soon as I do this, and you see that by default it becomes bars for each country. What I want to do is I want to change this from bar to a circle. As soon as I do the circle, you see immediately I have a dot for each of these countries. So let me make this smaller. So this is called a strip plot. Relatively simple. There is really nothing to do. Let me fit this to the height so that you can see. Here is a strip plot of distribution. Okay. It's not perfect. Yes, you can see it. But what we can do is we can make this more pronounced. So that's what we will do next. Okay. So we can actually take country, region, let's color it with region, okay? So now we can see how each region is, affecting, it's, where each region lies on this line, okay? One way to do this is to fix, so let's fix our axis. So let's start not from there, but let's start from, we can start conveniently from 45 even. Okay, and go all the way to the top, which is fine. Okay, let's do that. All right, so now it's shown. Now the next thing I want to do is I want to change the size of these a little bit, make it a bit higher, larger. Okay, all right, still not very good. It's so many countries. There are 200 plus countries here. I think maybe, I don't remember, 180 I guess. Okay, so what we will do is we want to next create each of these strip plots for each individual region, okay? Or GDP. Let's do one thing, okay? I'm gonna actually, first thing I want to do is add GDP. So let's copy this again, duplicate this, and now let's add GDP to size. So I'm gonna go ahead and take GDP per capita and add it to size, okay? Now, of course, let's make this size a little bit larger. All right. It's hard to see. Let me make this full screen so that we can see. All right. So now, so you can see each region, and you can actually, over time, you can actually, since we have year, we can actually go and look at how the population, how the life expectancy over the years changes. Okay, so you can see it's going up. To the right means people are living longer. Okay, and you can also see which region. So if you look at Sub-Saharan Africa, it's right here. Most of it is right here. Okay, some countries you notice are moving left, so going down and up. That's also important. That's something that we need to worry about. So here, different regions. Okay, Pacific. right? So you can see how it's changing. So this is called a strip plot. Of course, this is still very crowded because it's a single strip plot. The next thing what we can do is we can actually go ahead and create small multiples. Looking at the whole world in a single simple plot like this is very complicated. What we want to do is we want to create one more level. So it's relatively easy to do. What we will do is we're going to take our income and go ahead and add it into rows so that we can create one chart, one strip plot for each income group. Okay, and you can also look at the regions. So you look at the region. This is basically your Europe and Central Asia. Most of the high-income countries are there. There are a few others also in East Asia and Pacific. Okay, so like Japan, Australia, and New Zealand. Okay, and then you look at the next income group, high income group. Okay, so here is an outlier in the high income group. You can immediately see Equatorial Guinea. Okay, and there you see income is very high, but nonetheless the life expectancy is quite low compared to the rest of the countries in that income group. Okay, so now look at these. Shortly, we're going to look at these outliers and how do we decide what an outlier is and how we actually mark it. Okay, so here I'm doing it all visually, right? So there is really no calculation whatsoever. I'm just looking at visually and saying, okay, here are the outliers. Okay, here's a couple of outliers here as well. Okay, but we can also make it automatic. So here, classified. Let me actually see. I can exclude that. Okay, so right here, it's much better. All right. Now the next thing is what we will do is we're going to create what is called box plots. Relatively easy to create, but before I create them, let's go discuss what they are. Right? You must have seen them. You might have seen them in your stat classes, but nonetheless, I'm going to do it. Talk about them shortly. Okay. So we talked about strip plots already. All right. So now we're going to talk about box plots. All right. So I'm going to skip this picture for now. So what is a box plot? Box plot is a plot of all the points, just like a strip plot. So you can think of it as a vertical strip plot. So you basically list each country. You put a dot in each country. Of course, some dots will be closer to others, and others will be far away, okay, high or low. So what you want is you want to create a box around this so that you can find out the upper hinge, which is basically your quartile 3. A median, this is your quartile 2, and then your lower hinge, quartile 1, okay? And then the whisker shows you the low and the high, okay? So you want to create these whiskers so that you can see what is an outlier, so you can actually show an outlier. How do you decide how far the whisker should go? There are a couple of formulas. We're going to use some of the formulas, and I'm going to show you what is used in a Tableau as well by default. You can change it, but there is a default that's already used. Right? All right, so let's create box plots and we'll come back to this picture and talk about whiskers again. Now, box plot is relatively easily created in Tableau. All right, let's add a chart. So what I will do is I'm going to go ahead and grab my life expectancy. Right, you see by default is sum. I'm going to go ahead and get my country and put it in detail, and let me also use it in color. Okay, so here are my countries. At this point, you see that you're allowed to create a box chart. So let's click on box chart, right? So here I basically have sum of life expectancy, and here are my outliers. But this is not quite because I don't need sum. So I'm going to go ahead and turn the sum to average. Okay. As soon as I do the average, you see that now I have here my box plot, upper whiskers, lower whiskers, and median, and so on. Okay. So you notice now it extended these whiskers, but nothing is an outlier. This is not true. What we need to do is again get country to color. We lost that momentarily. And then take this average life expectancy and turn it into a dimension so that each country is treated separately. Okay? As soon as you do this, now you notice here is your lower whisker and here are your outliers. Okay? Of course, this is all years, it averages out. So what I want next is I want to take the year I don't want to average across all years. That doesn't make sense. I want to look at each year and see each year who is an outlier in the entire world. Once again, I can actually change these years and look at it. All right, so next thing I want to do is add income, and then let's income right here, so we can see each income group how it's distributed. So this is the not classified one. I'm gonna actually get it out of our way so that we can focus on the data right here. Okay, so now the next question is, how far does these whiskers go and how does it define? Here is your outlier, Equatorial Guinea. Here Angola is outlier, here Rwanda, and a couple of outliers in this compared to the group. So what it does is, boxplot does is, for each individual income group, it looks at its distribution and decides who's an outlier. Here are a couple of outliers. Estonia and Hungary are actually outliers compared to this. So what you do is you can click on this, right click and go to edit. You'll see that by default in this box plot, data whiskers extend to data within 1.5 times IQR. IQR stands for interquartile range. So it's basically the difference between the quartile 3 and quartile 1. So it's basically this difference. Now, if you look at this figure, you'll see that if you take these distances, you see that they are not equal. I mean, here, this distance at the top is not 1.5 times. They're not equal. So what is happening is, what Tableau is doing is the following. So when you go extend your whiskers, if there is no point beyond that, so you actually stop at the last point, okay? So if the whisker goes all the way up here, I mean, you notice it does. So if you take the same distance from here to up, it should go further, but it doesn't go. The reason is because it stops at the highest point, okay? So the best way to understand this is to look at the low income group. If you look at the low income group, the whiskers, this distance from this point to here, quartile 1, and this to up are equal. They have to be equal. So take this difference and then multiply it with 1.5 times. Okay, so that's what the whisker is. All right, that's where it stops. All right, so now let's go back to the slideshow and look at how we get to here. So if you actually go ahead and look at, we have these range bars. Okay, so this is what we did earlier. So the box plots are actually taking these range bars and take a look at each individual country. So we put a strip, one dot for each country, and we look at then the distribution and try to find out where the 50% falls. Okay, so each group. Okay, so now actually you can see the trend, but not only the trend, but you can also see. So as the income goes down, you see that average life expectancy goes down, but at the same time you see the entire distribution. By comparing these boxes and then the whiskers, you can see how the distributions are overlapping or changing across different groups. Okay, this is quite useful. So the separation of outliers, there are many ways of doing this. We're going to use John Tukey's original design. So what is going on here is you calculate the IQR, interquartile range, and then that's basically Q3 minus Q1, and then you take this value and multiply it by 1.5 times, add that to third quartile, subtract from the first quartile, and then you find your whiskers how far. Of course, at any point in time, if the whisker goes beyond the last data point, you actually limit it at the last data point. Okay, so that's what Tableau does. All right. So you can, once your outliers are adjusted, you can now see where your outliers are in your data. Okay, here are some outliers. You can do also multiple strip plots. We have done that. So the idea is, in the distribution analysis, the best practices: keep intervals consistent, select the best interval, and use measures that are resistant to outliers. Like mean is highly susceptible, median is not. Okay, so let me give you an example. I have this example right here, so I'm going to expand it. So, sorry about this. Let me move it right here and expand this. All right. Suppose you have these data points. Okay. So the data points we have are these basically. So, okay. So let's add some outliers. So as soon as, suppose that your blue are data points and then you have two outliers, one is red, other one is purple. So without outliers, this is what your line will look like. But as soon as you add outliers, what happens is, since you have this line, so the current line, this is your best line without outliers. So let me write it with blue. So this is the best line without outliers. If you have outliers, what happens is this error, this box right here, remember that squared error, becomes huge compared to these small ones. Okay. So now what your data will do is, you'll try to fit a line closer so that this error becomes smaller. Of course, in the meantime, these errors also getting higher, right? But compared to that huge box, those small errors that you're getting by moving your line up are going to be tolerated. Okay, so this is what outlier will do. Same thing will happen in the purple case. So in the purple case, your line will start to move below so that it avoids this huge error. This is your huge box. You're trying to avoid that as much as possible. Get closer to this, sacrifice these errors in the meantime. Okay, there's a small one right there. But so the outliers actually, when you do regression, outliers actually take your data and then skew it quite a bit. Okay, so that's why they're important. All right, let's now go back to our data set and create some histograms. All right, so what we're going to do is, so the histogram is relatively straightforward in Tableau. So you can take a data set like life expectancy. All you need to do is go to show me and click on a histogram. So this will actually give me a default histogram. Okay. So what it does is actually creates these bins, and then it gives me the count of numbers in each. So this is the whole number. Of course, I want to do this for each year. I don't want to. Okay, let me get the discrete version. So I want to do it for each year, see the distribution, right? Now, of course, this bin is set. So let's go ahead and look at the bin itself. So this is defined to be a variable. Now this is one way to do it. Another way to do this is, which will give us more control. So you can actually choose the variable and right click on this and go click on create and then create bins. Okay. So now this is going to be your life expectancy, right? So, and then I'm going to call this bin. So the size of the bin, it gives you a size. You can actually click on this and it is the size that's recommended, and that's what the default size was. You can actually choose to create this. You can change this to any number you want, or the best option is to go and choose to create a new parameter. So what this will do is it will now create a life expectancy. So let me fix this. See parameter, and this parameter can now be changed. The current value can be 2, just let it be 2 for now. And then we can actually choose it to be a range from, let's say, from 0 all the way to, I think that's what we did, 16, and then get rid of the step size. Okay, click OK. As soon as you do this, what it will do is it will create a variable called life expectancy bin. It will also go ahead and create a parameter for you. Okay, all right, take the life expectancy, put it in columns, and go ahead and take life expectancy and go ahead and now, not the sum, but let's go ahead and count it so that we can see how many are in that specific range. Now what we can then do is we can add years to pages, okay? And then the next thing I'll do is I'm going to actually go ahead and say take this life expectancy parameter and show the parameter control. So you notice now the parameter control will be a slider. I can choose, and then it will basically change the bin size. Okay, so I think it's about 2 was what I did in the version I posted. You can also change this. You can click on this and say instead of slider you can show type in, so that now you can actually go ahead and type the value you want. Okay, so right, so it will immediately change your histogram. So let me duplicate this. I'm going to do a few more things. Now, histograms are good, but you can actually look at histograms for various groups. What you can do is, for instance, you can look at it in income groups, right? So each income group, you can actually see how the distribution is. So you can actually see the same thing. Here the distribution. This does quite a bit the same thing as box plot, but it's another way of looking at distributions. I can also add one more variable into this. I'm going to duplicate this, and now I'm going to go ahead and add region, and then I'm going to add it right here in the columns. Okay, so now let me fit this to the screen so that you can see. Now you can see in each region, each income and region, you can actually go ahead and see how the distribution is for that specific region. All right, so this is your trellises. Okay, and then this is like small multiples. All right, so that's it. Now the next thing I'm going to do is I'm going to go ahead and look at correlation analysis. For the correlation analysis, the point is we're trying to find out if two variables are related to each other. Okay, of course it can be causality or not. You have to be really careful about causality issues. For instance, if you take a look at these two variables, salaries of professors and beer consumption in the nation, they are highly correlated, but you can think like, which causes which? I mean, do we get higher salaries when we consume beer, or is vice versa? It's actually neither. So what's happening is actually there is a third variable, third factor that's affecting both of these variables. Okay, like state of the economy. So if the people are wealthy, they are to consume more anything, including beer, and of course the salaries of faculty members go up if the state of the economy is good. Okay, so when we look at correlation, we're going to worry about the direction, positive, negative. We'll also worry about strength, strong, weak, and also talk about shape. But remember, understanding correlation is not that easy. Correlation coefficient may not be only a variable. You have to really combine the correlation coefficient along with the visuals that you have. Okay, so we'll do that using adding trend lines and also looking at correlation coefficient that basically is the coefficient that gives us the best line possible. All right, so we'll do scatter plots, scatter plot matrices, table lenses for correlation analysis. All right. So the first thing I'm going to do is I'm going to look at the GDP per capita and compare it to the life expectancy. All right, so let's do this in Tableau. This is relatively simple to do. So I'm going to go get my Tableau up. All right, so let's go and add a new chart. So let me get out of the full screen. So what I want to do is I want to look at average life expectancy. All right, turn this to average. I'm going to look at it across, of course, each year. Let me add my year to pages, and then I'm going to look at compare it to GDP. So I'm going to look at it again, compare it to average GDP. All right, let's do this again. All right, so you see that the average GDP is around what, $8,000, okay, for 1990. Okay, all right, and then the average GDP is around 8,000, actually, $7,500, and the average life expectancy is 64 in 1990, right? So simply you can actually go look at over years. You see that this is going to actually move, okay, move up and to the right, right? So the next thing is I want to look at each individual country. So I want to get the country and put it in detail. So I want to see the distribution. Now you look at this distribution, is highly concentrated on the left side. Okay, there are a lot of countries which has average income around 20K. So this is kind of very focused right here. So this is kind of data where changing your scale becomes very important. So this scale is now linear. I want to change this so that I can actually see the relationship. It's very hard to see what's going on here. So what I want to do is right click on this, go to edit axis, and make this logarithmic. Okay. So now as soon as I do this, I'm going to get rid of the small value. So let me also change it. You notice there's nothing below 100. So I'm going to change that from automatic to fixed and start from 100 and go all the way up to this, which is fine. Okay. So now you can see now that relationship. Okay. It's hard to see when you don't have the proper axis. Now you can see. The reason is because as the income grows, your life expectancy doesn't go up much, right? So it only goes up logarithmically, okay? Right? Right, so the logarithm of the income, okay? Because additional dollars doesn't make your life easy. At the beginning it does, but as it gets larger, it doesn't impact as much. Okay. All right. So this is for 1990. Let's look at 1990. Here, what we can do is we can actually go and look at each year. Play this. You'll notice now countries are moving to the right. Okay. And then up. Higher income and then higher, longer life. Okay. So we can actually see this. This is quite nice. All right, so let's add color. So let's add countries to the color so that we can actually have some color so that we can see different countries. The next thing I'm going to do is I'm going to go ahead and add trend line to this. It's relatively easy. Right click on this, trend lines, and then just click on show. And of course, this is now what I'm going to do is format this. So not format this. Let's change this, edit trend lines. What I want is, I don't want country here, okay? And I want this to be, all right, so let's click on this. All right, so let's look at the line. So this is what the line is, right? Average life expectancy, right? Which is a logarithmic of income. So it means it increases only in the logarithm of the income, all right? So it's kind of, you can think of it as, and the R square is around 0.6. This is quite a nice relationship. All right, what next we'll do is, we're gonna look at, again, do trellises and look at it in multiple regions, right? So what I wanna do is go add region, all right? And so that we can see how it changes in each region. So let's fit this to the height so that we can see, right? So here are a couple of regions. In each region, the income actually increases your life expectancy. But if you look at the average life expectancy in, let's go to 1990. So in the low income region, East Asia Pacific, sorry, not low income, East Asia and Pacific, you see that this increase actually makes a huge impact. So as your income goes up, your life expectancy goes up drastically. Not as much in Middle East and Africa, North Africa. Income doesn't impact it as much, okay? So what we can then do is, we can now make this large and then play. Let's see how it's changing. So what is happening is, over these years, okay, so let me play this, okay? So notice lines, the slope of the line goes down. So it means as time passes, the effect of income on your life expectancy softens, okay? So as you become richer and richer, which is what's happening here, and as you live longer and longer, the additional dollars that you get doesn't impact your life as much, okay? It doesn't extend your life as much, okay? So it's all about that dollar, that the marginal utility of dollar actually goes down as you have more and more wealth and income already, okay? All right. So if we go back to our /show, so here is the relationship. So the relationship is quite reasonable, actually, meaningful. So R square is quite high. On top of that, this is our line, okay? So for each group, the line is representing how much your income is affecting it's affecting, but it's not affecting as much as you wish as you have more higher income. There are other effects, right? So health issue conditions are there, wars are there are all kinds of other external effects of effects on the life expectancy. Right, so we then looked at fit across regions. So one of the good practices in the correlation analysis is basically optimize the aspect ratio, okay? So on the, your X and Y axis, make sure that you have that optimized. Remove color and reduce overplotting. So that's what we did. What we did was basically we created each region separately instead of overplotting it in the one single like this, right? So we basically take first the linear and then we look at each region separately, okay? Now, then visually distinguish data sets in divided groups. That's what we did. We used trend lines. if you removed additional values so that you can look at each region separately. Trellis and cross-tab displays to reduce complexity. We did small multiples. And grid lines when they help comparisons, otherwise you remove the grid lines, okay? And we did some of this in assignment 2, and you're going to do more of it in assignment 3, all right? Now, one thing I want you to note, if you look at all of the regions, okay, I'm going to go back to our tableau, and I'll ask you one question. All right, if you look at all the regions, income is affecting your average life expectancy positively. There is one region, however, it's negative, right? Look at North America. Well, because this is in Canada and this is United States. Even though GDP per capita is much higher in the United States, Canada has higher life expectancy. And why is that? Well, it's partly because they have better medical care and social systems in place. But nonetheless, this shows us that 2 data points. Whenever you have 2 data points, there is a line. If you look at this line, r squared is 1. There's always a line that you can cross through 2 data points. And another thing is that 2 data points, whatever line you get here, it has no meaning, okay? So you can actually say this is an outlier because the sample size is so small, this line, you can actually ignore this. All right, this is all I have for this group distribution. So histograms and correlations, that's what we did this time. All right, talk to you next time about best practices for charts.